This is section 8.2, part C, putting it all together with the 4-step process. So when you're creating a confidence interval using the 4-step process, remember your 4 steps are going to be state, plan, do, and conclude. For state, you want to know what parameter do you want to estimate and at what confidence level. For plan, you need to identify the appropriate inference method and you need to check your conditions. On the do step, if the conditions are met, perform calculations. And in conclude, you need to interpret your interval in the context of the problem. So let's do a 4-step problem. The Gallup Youth Survey asked a random sample of 439 U.S. teens aged 13 to 17 whether they thought young people should wait to have sex until marriage. Of the sample, 246 said yes. Construct and interpret a 95% confidence interval for the proportion of all teens who said yes if they were asked this question. So the first thing we're going to do is our state. We want to estimate the actual proportion P of all 13 to 17-year-olds in the United States who would say that young people should wait to have sex until they are married at a 95% confidence level. Next, we're going to come up with our plan. So first, you're going to say what you think you should do, and then you're going to check your conditions. So we should use a 1-sample Z interval for P if the conditions are satisfied. And remember, the 3 conditions you need to check are random, normal, and independent. It is stated in the problem that the Gallup survey is a random sample of 439 U.S. teens. So the random part is met. When we're talking about proportions, you need to check for normal by making sure the number of successes and the number of failures are each at least 10. Now in this case, a success is if they say yes, and we know that's 246 people. And since there were 439 U.S. teens surveyed and 246 said yes, that leaves 193 of them to say no, but both of those numbers are at least 10, so we can assume normal conditions and use normal approximations. Because they did not sample with replacement, we are going to have to check that 10% condition. So if we do 10 times our sample size, that's going to give us 4,390 U.S. teens. As long as we assume that there's more than 4,390 U.S. teens that are aged 13 to 17, then that 10% condition is met. Now we need to do the work. So your P hat in this case, or the proportion for your sample, is 246 said yes out of the 439, which gives us a 56%. If we're going to do a 95% confidence level, remember when you're dealing with a confidence level, that's telling you the inside part. So we want the inside to be 95%. So that's going to leave us 5% for the 2 tails, or 2.5% for the left tail, and 2.5% for the right tail. So we're going to look on our table for an area of 0.025 and see what the value closest to it is. If you look at your table A, you're going to see that an area of 0.025 is going to correspond to a Z value of negative 1.96. Your Z star value is always going to be the positive version of that, so our critical value is going to be 1.96. Now to construct our confidence interval, we are going to use this formula. We already calculated that our P hat was 0.96, our critical value is 1.96, and we know our sample size is 439. So this is going to give us an interval of 0.514 to 0.606. So for our conclusion, we're just going to bring that all back together into the context. And we can say that we are 95% confident that the interval from 0.514 to 0.606 captures the true proportion of 13 to 17-year-olds in the United States who would say that teens should wait to have sex until marriage. Now you do need to be cautious. Remember, the margin of error in a confidence interval includes only sampling variability. There are other sources of error that are not taken into account. As in the case with many surveys, we are forced to assume that the teens answered truthfully. If they didn't, then our estimate may be biased. Other problems like non-response and question wording can also affect the results of this and any other poll. So a good lesson, sampling beads is much easier than sampling people, because beads can't lie. When you go to take your AP exam, If a free response question asks you to construct and interpret a confidence interval, you are expected to do the entire 4-step process. That includes clearly defining the parameter and checking all of your conditions. Also, when you go to take your AP exam, you may use your calculator to compute a confidence interval on the AP exam, but there's a risk involved. If you just give the calculator answer with no work, you will get either full credit for the due part if you got it right, or you can get no credit if you got it wrong. If you show your calculations and you do make some mistakes, they can give you some partial credit. So it's probably better to use the appropriate formula, show your work, and then check your answer with your calculator. If you opt to use the calculator method only, be sure that you name the procedure, such as a 1 proportion z interval, and you give the interval. Now, if you do want to do this on your calculator, you can do this with an 84 calculator. So on that last example, our n value, or our sample size, was 439 teens, and that our number of successes was 246. So to do this, you would press the stat button, you would choose test, and you would go down and select the 1 proportion z interval. When you're there, your x value would be that 246 who were successes, your n value would be 439, or your sample size, and your confidence level will be 0.95. After you calculate this, it should show you the proportion for the sample, or the p-hat value. It'll show you the interval, and it will show you the sample size. Now, it is possible to have a desired margin of error, so you want your answer to be accurate within this much of your confidence level. If you have a desired margin of error, you can use this formula to calculate what your sample size needs to be. Now, you don't always know what that p-hat value is, so if you want to have the n value or the sample size as large as it possibly can be, then you should always estimate that p-hat is 0.5. So if you have no other information, assume p-hat is 0.5, and that'll tell you the largest possible sample size that you could need. So a company receives a complaint about its customer service. The manager intends to hire a consultant to carry out a survey of the customers. Before contacting a consultant, the company president wants some idea of the sample size that she will be required to pay for. One critical question is the degree of satisfaction with the company's customer service, measured on a 5-point scale. The president wants to estimate the proportion P of customers who are satisfied, which means they either chose satisfied or very satisfied, which is the 2 highest ratings on that 5-point scale. She decides she wants the estimate to be within 3%, or 0.03, at a 95% confidence level. How large of a sample is needed? So you would start with that formula with the margin of error. We know that with a 95% confidence level, again, you have your bell curve, you have 95% on the inside. That's going to leave 2.5% on the left and 2.5% on the right, or an area of 0.025 for table A, or your Z table. And if you look up the corresponding Z value, we will find a critical value of 1.96. Now, we know that our margin of error, we want to be no more than 0.03. So if we plug in our critical value and our margin of error, now we can solve or start solving for the n value. The first thing we can do is we can split this up and write this as 1.96 times the square root of p hat times 1 minus p hat all over the square root of n is less than or equal to 0.03. We can multiply both sides by that radical n to get it out of the denominator. And then we can go ahead and divide both sides by the 0.03 to get the radical n by itself. We want to get rid of that square root, so we can square both sides of the equation. By doing that, our fraction will be squared, and you'll get rid of the square root over the probability of success and probability of failure. In this case, we don't know what the p-hat value is, so to make the largest sample size we could possibly need, we're going to let our p-hat value be 0.5. So if we substitute in that value of 0.5, Our failure rating would also be 0.5, or 1 minus that 0.5. And we would get an N value of 1067.111. We're going to go ahead and round up, and we would tell the president that they need at least 1,064 respondents to ensure that the margin of error is no more than 3%. As usual, smaller margin of errors call for a larger sample. So let's check our understanding. We're still talking about that company and the president who wants to hire consultants. But in this case, if the company's prior year survey, 80% of the customers surveyed said that they were satisfied or very satisfied. Using this value as a guess for p hat, find the sample size needed for the margin of error of 3% at a 95% confidence interval. So this time we're going to use previous information from a different year to estimate with our p hat to get a more accurate sample size. So we're still going to start the exact same way. You still have the same critical value because we're still doing 95%. You still have the same margin of error of 0.03, but in this case we do have a p hat value. Again, we can separate and we can divide both sides by 0.3 first, which will give us 1.96 over 0.03 times, we can separate this and write this as our 0.80 times 0.2 all over the square root of n is less than or equal to 1. We can then multiply both sides again by that radical n to get it out of the denominator, and then we can square both sides to get rid of that square root. By doing the calculations, and we round, we can say if we estimate a p hat of 80% instead of 50%, they would only need 683 respondents to ensure that the margin of error is no more than 3% if we assume that p hat is 80%. Now, what if the company president demands a 99% confidence interval instead? Determine how this would affect your answer in question 1. Now remember, if you want a larger confidence interval, you are going to have to increase your sample size. So we do know that the sample size would have to be larger than it was for question 1. This time we're going to have to find a new critical score or critical value. If we have a 99% confidence interval, so 99% on the inside, we only have 1% left, or 0.5% on the left and 0.5% on the right. So you would look on your table A or your z-value table of an area of 0.005 and find the corresponding z-value. It's going to fall between 2.57 and 2.58, so we're going to say our critical value is 2.575. Our margin of error is still 0.03, so you'd go through the exact same process. The only difference is that critical value. And this time, if we round up, we're going to get 1,179 respondents to ensure the margin of error is no more than 3%. Again, we are going to have a larger sample size if we want a larger confidence level.